Hello, folks. So this is part 9 of the Learning Rust series, and today I'm on day 4 as part of the 100 days of Rust. So the last exercise that I'm like looking at as part of this video is basically again around variables, and I have this error saying const number equal to 3, so it says missing type for const or static. Okay, so it is here, and they're printing the number. And if you see here, it says missing type for const item, and then constant item. Help provide a type for the constant, so number integer 32. There's no error code, but it's interesting that let's say if I put let, what does it do? Okay, I can't do let over here. Expected item found keyword. Okay. Const is fine, but not let. Okay. Interesting. So this is called item, const item, and not a keyword. Let's just get rid of this. Not found in the scope, and then we give const, and then we give let. So this works. Interesting. So if I do the same thing here, it doesn't work. Right? So it says expected item and found keyword. So it's expecting an item. I don't know what's an item. And let is a keyword. So I'm guessing const is an item. And here it says missing type for the const item. And for let, you don't have to mention your type. The compiler is able to infer from it, unless it's not able to infer. Like when it's not able to infer like a unique type, unambiguous unique type, then it'll ask you and it'll give you error saying, hey, give a type annotation so that I can understand the type partially or completely. Partially as much as I can, you can give so that it can infer. In this case, it's a constant number, but it's not able to infer from this that this is a integer. It's an interesting thing. We'll put I32 here, and awesome, it worked. Let's also check out the hint for this to understand what's going on here, why it can't infer, right? So we know about variables and mutability. Yep. So this is a constant, but there is another important type of variable available called constants. Okay. Constants are always immutable here, and they're declared the keyword constant. It's still a keyword, and rather than the keyword let. Okay. Constants must also always be annotated. Okay. So type annotation must always be there. Read more about constants and the differences between variables and constants under constant the book section, variables and mutability. Okay. Cool. I think we can read about it here. It was just about shadowing basically. So constants like immutable variables, that is like, when you say let, it's still immutable only. Constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables, like constants and immutable variables, because constant is also immutable. So first, you aren't allowed to use like only const. With constants aren't just immutable by default, they're always immutable. What's that supposed to mean? I mean, if you say let mute, it's just immutable, right? Um, they're always immutable. Maybe with let, you can also do both with mutation and without mutation, like immutable. You declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. We're about to cover types and type annotations in the next section. Okay, this is like as part of the book. So don't worry about the details right now. Just know that you must always annotate the type. Constants can be declared in any scope. Okay, so it's not just including the global scope. So we have a global scope here. And then we have the function main scope here, which makes them useful for values that many parts of code need to know about. The last difference is that constants may set only to a constant expression, not the result of a value that could only be computed at runtime. Here's an example. Okay, so this has to be a constant expression. The constant's name is 3 hours in seconds, and its value is set to the result of multiplying 60 the number of seconds in a minute, by 60 the number of minutes in an hour, and by 3 the number of hours we want to count in this program, and so on, right? So and it's also annotated with the unsigned integer third of it. Compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write out this value in a way that's easier to understand and verify rather than setting this constant to the value 10,800. See Rust's reference section on constant evaluation for more information on what operations can be used when declaring constants. Okay, so you can do this, but you can't do something like a some variable value that you put in that can only be computed at runtime. Constants are valid for the entire time of program runs within the scope they were declared in, of course. If it's global, so it's globally there. And this property makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn or the speed of light. Okay. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value to future maintainers of the code. Yep. Instead of having magic numbers and magic constants, you can name those constants and like have named constants, and then the values can go in somewhere in a central place or like any appropriate place. So it also helps to have only one place in your code you would need to change if the hard-coded value needed to be updated in the future. Fair enough. Yep. You avoid duplication and problems of duplication. Cool. And like do not repeat yourself stuff, right? So with that, this exercise is pretty cool. We have done it. That's all I had for this video. I'll see you on the next one on another exercise. Bye bye.